All right, this one is our proofs that involve CPCTC. And CPCTC means congruent parts of congruent triangles are congruent. So these proofs, typically we're going to have to prove that the triangles are congruent in order to prove that there are parts of them that are congruent. So we're going to have to go one step beyond what we've been doing. So we need to prove that an angle is congruent to an angle, not that a triangle is congruent to a triangle. So that's going to be the difference in these kind of proofs, okay? So let's go ahead and start where we've always started. We're going to mark it out. EF congruent to GF, DF congruent to HF. That was not my greatest marking, that's okay. Marking my vertical angles. And we can see right off the bat that this is a side angle, side congruent triangle. Okay, that was pretty darn easy. But what do they want us to prove? They want us to prove that angle DEF, which is, let's see, I'm going to get a different color, pink. DEF is up here, is congruent to HGF. All right, we wouldn't be able to prove that normally. But since we've been able to prove that the triangles are in fact congruent, we can now use CPCTC to say, since the triangles are congruent, all their parts are congruent. So we can take it one step further. So that's what we're going to do. All right, let's go over here and do that. So let's send them to proof. Let's do our vertical angles, EFD, congruent to GFH. Vertical angles. Let's prove that the triangle. So now we actually have to say triangle. The cool thing is the triangle order will be in the same order as those angles. So if you don't want to have to sit there and try and figure it out, you can do it in the same order as the angles. The triangle DEF is congruent to triangle HGF. And it's because of, we decided side angle side, validate. Okay, now that we know that the triangles are congruent, we can now prove that those angles are congruent because congruent parts of congruent triangles are congruent. And there is your proof. All done.